Welcome to CATS Tutorials, and in this video I'll be covering practice problem 11.6. We are told that this RL, which is a resistor, so this is a resistive load, and we're told that it's actually adjusted to absorb maximum average power. And we're asked to find the value of this maximum average power as well as the value of this resistive load. So for a resistive load to absorb maximum power, we know that the value of the resistive load has to be equals to the magnitude of this thevenin equivalent impedance. So now let's go ahead and find the thevenin equivalent impedance, and we are going to find its amplitude after that, or its magnitude, its magnitude after that, which is going to be the value of RL for maximum average power, right? So taking this out, we're going to take all independent sources inside out, which is this one only. So that's going to be a short circuit, which means when we compute our ZTH, we're going to have AT plus J60, which is going to come from the combination of those two. So AT plus J60 in parallel with 90 degrees. Not 90 degrees, this is 90 ohms, sorry. And here we're going to have negative J30 in ohms as well. And we are computing, or interested in finding our ZTH with respect to where we have the load. So this ZTH we can find just by combining all of these in parallel, which can be done by doing this. All right. Now putting this into your calculator should give you a ZTH of 17.18 subtract J24.57. Now finding the magnitude of this, which is going to be the value of our RL, is the same as saying 17.18 squared plus 24, so plus 24.57 squared. So the amplitude of that, or the value of our RL, is expected to be 29.98, which is approximately equals to the 30 ohms, which is written in the textbook, right? So that's one part of the question, which was the value of RL for maximum average power. So now we have to find this value of maximum average power. And to do so, we need, so we're going to use this formula, which says half the magnitude of I squared multiplied by the value of RL. So we're going to find the maximum power, which is absorbed by this RL using this formula. So to do this, we first have to find VTH. And if we come back to this circuit, we can basically combine these two in parallel, right? So we're going to have 90 in parallel with negative J30, form an impedance over there. And our VTH is going to be measured from here, which means VTH is the same as the voltage which is across this parallel combination over here. So VTH is across this point. So we can just go around this loop to find the value of I, or we can just do voltage division. So to find VTH, you can just do voltage division, because VTH is the same as the voltage which is across this parallel combination of the impedances 90 and negative J30. And so VTH, by doing voltage division, so 120 with an angle of 60 degrees multiplied by the parallel combination divided by the parallel combination, the value of it, plus 80 plus J60, and the VTH which you should find should be 35.98. So it should be 35.98, right? With an angle of negative 31.909 degrees, and that is in volts. So that should be your VTH, which you find, right? after doing voltage division to find the voltage which is across your parallel combination of 90 and negative J30. So now that we have our VTH, we can proceed to find the I, which is the current which is across the load. And we find that using this formula, which is VTH divided by ZTH plus RL. So you can basically just substitute all the values. We have all these values. And the value you're going to find for the current across the load is this. Right? Now that we have this, we're going to take the magnitude squared to find the maximum average power. So the magnitude squared, then we're going to multiply that by RL, which we said to be 30. Now this should give you a value of 6.855 watts, which is your expected maximum average power.